In this part of our video, I will be discussing the most important concepts of the video. Further discussion of concepts. It's absolutely important to notate that we do see the importance of managing accountants, and we absolutely aware that all of those help managers principally with inventory evaluation, product costing, costing of services, product pricing, break-even analysis, product line or probability analysis, decisions to downsize department and lay off people, decisions to discontinue product or product line, preparation of budgets, and forecasting, which is sales and expenditures. We do see on the previous modules all of the concepts over here, and in this one we're going to be reaching preparation of budgets, and we're going to be seeing also forecasting. According to this video and the concepts that we're going to be working with on this video, it's important to know that we're supposed to be knowing prior to understand this module concepts about product cost, period cost, variable cost, fixed cost, semi-variable cost, prime cost, and conversion cost as the primary ones. But it's also important to note that we should know about relevant costs, opportunity cost, sunk cost, marginal cost, and marginal revenue. On this module, we're going to be working principally with prime cost and conversion cost, marginal revenue, and then we're going to be working with marginal cost. As we're going to be starting with prime cost and conversion cost, it's actually really simple. We have direct material, we have direct labor, and we have overhead in our business. And what is going to be the primary cost is going to be direct material plus direct labor. And what is going to be conversion cost is going to be direct labor and overhead. Just to understand prime cost and conversion cost and which one are the difference between all of them, but also understanding that it's all of them depends directly from direct material, direct labor, and overhead. As we can see over here, I'm representing marginal revenue, which is incremental revenue generated by selling one additional unit. That will be our marginal revenue. On the example over here, we have one unit, and the total sales revenue is $50. The marginal revenue then will be $50. And then we have units, 2 units. The total sales revenue will be $95. And the marginal revenue will be 45, which is the difference between 95 and 50. Then we have 3 units, and the total sales revenue is going to be $120, and the marginal revenue will be 25. Then we have a total of 4 units, and a total sales revenue of $144, and a marginal revenue of $24. As we can see in the graph, it only decreased, the amount of units decreased, and also the amount of money. Less units, more money. More units, less money. So that will be the graphic. It's a decreasing graphic over here. Basically, that means that if you sell more units, the incremental revenue reduces. Now that we understand Okay, now let's go ahead with marginal cost concept, and it's basically incremental or additional cost associated with making an additional unit. From over here we have the example, we have units, total cost, and marginal cost. From one unit, the total cost for that unit will be $100, meaning that the marginal cost would be $100 as well. Then we have 2 units, and the total cost for that 2 units is increasing. It's going to be $180, meaning that the marginal cost meaning the difference between those $100 and $180 will be $80. Then we have 3 units for a total cost of $255, and the marginal cost will be $75. The difference between 180 and 255. Now we have 4 units. For those 4 units, the total cost will be $320, and the marginal cost will be $45. If we go ahead and take a look to our right, we will have the graph. And it's basically this. Marginal cost declines initially, but at some points the company or the business may need to invest again due to the amount of units or due to the amount of the product that they may need to produce for that time. So if we see the first part of that graph showed us that the price, it's going to decrease with more amount of units, but eventually they may need to reinvest in more people to work on it, or they may need to reinvest. That's the word. So that's why, then that's basically why then the graph goes and increase again, because the price is going to increase depending on the amount of units. That's basically marginal cost concept. Now that we understand concepts about marginal revenue and marginal cost, we have a question over here in our video, and it says, at what level of output can we maximize profits? Okay, and why it is important to know and understand both of this. Actually, what it says, or what the graphic says, is that we can maximize revenues when MR is equals to MC at some point of the graph. So in our next slide, I will be explaining a little bit more about both of these concepts, and I will go ahead and represent the graph so we can better understand at what point or at what level we maximize profits in productivity terms. Now we're looking to understand why are all of those concepts important. Well, it is important because at some point of the production we will need to know the maximum point of revenue. We have a really interesting graph over here in the one we're mixing MR with MC. What that means is that if we start taking a look on the left hand of the graph, we can see that MR is greater than MC. What that means is it's that we can increase profits by producing more units because the marginal revenue is greater than the marginal cost. So at this point we can keep producing, as we see over here. If MR is greater than MC, we can keep on producing. By the other hand, if we take a look on the right hand of our graph, on the right side, at this point don't make any more or don't produce any more because we are losing money. If the cost is greater than the additional revenue, at this point we're not maximizing productivity or profits. So at this point we don't need to produce anymore because MR is less than MC. So the best point for keep on producing, or the optimum output to maximum profit, will be with MR is equals to MC, which is at the middle of our graphic from over here. That will be the best way to resolve, and it's a really good example of MR and MC, and at what point we are going to have maximum point of revenue. Okay, so at this point we have an example given to analyze marginal cost and marginal revenue, and it's in R squared number 1, It says Allen Brothers has designed a machine for sorting apples that is able to detect bruises or an apple. Bruised apples are used for making applesauce. The apples without defects are shipped to grocery stores. Managers at Allen Brothers are uncertain of the demand for these sorting machines, but have estimated the following cost of making different numbers of machines. As we can see, the estimated is in our graph number 2, and we have certain amount of machines and the total cost per machines that is going from $100,000 to $500,000. And now we have questions in regards this data that they gave us. And the first will say that we may need to assign a table showing marginal cost. So it's right to the left hand, and it says marginal cost per machine. For one machine will be $100. For two machines will be $150, which is the difference between $100,000 and $150,000, as we mentioned on the previous slides. And we have all the marginal cost per machines, per the number of machines. And then we can jump to the next question, that is, what does the marginal cost increases after 6 machines? After 6 machines, as we were checking on our marginal cost graph, at some point this company may need to reinvest because they may need to produce more. So that's why at that point, at the number 6 machine, we jump from $30,000, to $60,000 with reinvest. In that, as the total cost increases, the marginal cost increases as well. Now let us jump to the point number 6, that is, what is the average cost of make 5 square machines? That in our slide, in our square number 3, we can mention that the average cost is equal to the total cost divided to the number of machines. In that case, we're talking about 5 machines. So we take $250,000, which is the total cost for make 5 machines, and we divided that into the number of machines, which is 5. That gives us a total of $500,000. Now let us jump to our point number D, and the question is, at what level do we maximize profits? If one sewing machine can be sold for $7,000, how many machines will we produce? And the answer is really simple. We have the marginal revenue in our square number 4, $700,000 per machine. And with that, we can take the marginal cost, which is going to be the cost per machine over here. Now let us take the marginal cost, which is the difference between marginal revenue, marginal cost, and total revenue. So the theory told us that at the point that MC is equals to MR, that's the maximum profit. So if we take the slide number 1, it doesn't help us because marginal revenue is less than marginal cost, meaning that we're investing more but we're not making more money. So from the number 2 till the number 8, we do have possible scenarios to maximize profits because marginal revenue is rated, whereas we know the best scenario is in the one we try or we equals MC with MR. So in regards to that, my theory is that at the point of 8 machines, that is $7,000, the marginal cost will give us $600,000, which kind of equals to marginal revenue. So make 8 machines